All right, let's continue our conversation about Kafka architecture. And we're going to talk about right now on the role of the controller. Okay, so first of all, what is the controller? The controller nothing more is than a specific broker that lives inside a Kafka cluster that is responsible for a lot of administrative operations, like creating or deleting topics, adding partitions, assigning leaders to those partitions, monitoring failures. All right, it's a role of the controller to propagate all of those metadata changes to the other brokers inside the cluster. Okay, so within a cluster, one broker will be elected as the controller, and then whenever something happens, it will propagate all of those changes to the other brokers. But how does how does the controller get sense of what has changed to be able to propagate it? So until very recently, we had the role of the Zookeeper. All right, the Zookeeper is an external coordination service that exists that is the centralized metadata store and works with the controller to help with the coordination inside the Kafka cluster. Okay, so it was going to interact heavily with the controller broker to manage all of the cluster. So the Zookeeper will be the one responsible for electing the controller. We're going to store the metadata about the cluster. What are the list of the active brokers? What are the configurations of the topics? The ACLs that are defined. And the Zookeeper will be the service that is going to send the changes to the controller. So let's say a new broker joins the network or joins the cluster, or a broker left the cluster. So the Zookeeper sends those information to the controller or the new controller, and it's going to propagate all of those metadata changes to the other brokers inside the cluster. Okay, so what are the drawbacks of having maintaining a Zookeeper here, this external system? The first one is that there are two services now to operate. So you do have the Kafka cluster and all of the brokers inside of it. And you also have the Zookeeper, an external service. So you need to operate those two. And it's kind of slow and complex when you have a controller failover. So say the controller here goes down, right? In a large cluster, whenever a new controller pops in, elected by the Zookeeper, it needs to load all of the metadata that is stored in the Zookeeper when it starts, and many times that's a lot of data. We have tens of thousands of partitions to read. We need to notify all of the other brokers about this change. So having this metadata spread outside Kafka makes it really hard to perform those updates, upgrades, and all of the tooling related to the broker. So to the cluster. So a solution or a new architecture that we're going to use when setting up our clusters here for the course is the KafkaRaft. Okay, this basically removes the Zookeeper dependency because it now uses the Raft protocol to manage the cluster metadata. If you're not familiar with this, it's not the scope to go very deep into this. You can search it by yourself. But Raft is a consensus algorithm that's going to ensure that all nodes in a distributed system will agree on the same state even if some fail. So there is an algorithm that makes sure it's all right. We have 10 nodes. We're going to agree on the same state. If one fail, we know how to agree. So in this case, using KafkaRaft, the election of the leader that's going to manage the log replication to the followers will be conducted inside Kafka and not externally. So that also helps guarantee the consistency and fault tolerance through majority agreement. So we call it a quorum. And finally, it allows the brokers themselves to agree on metadata and elect a controller internally. So everything, most of the things that were further before managed by the Zookeeper itself, all of the metadata that then needs to be propagated to the controller, We will let the controller propagate this, and then the controller will propagate to the other brokers. Now with the KafkaRaft, everything is now managed internally in the cluster. Okay, not needed to be super proficient about this. I just want you to know, because you see in the next lesson we're gonna start spinning up our infrastructure using containers. So you'll see, if you look into internet, you'll see a lot of Zookeeper images flying around, but we're going to use the Kafka Raft next. All right, see you on the next lesson.